Assalamu alaikum. Welcome to my YouTube channel. Today I am going to discuss how to implement adaptive neuro-fuzzy inference system in MATLAB Simulink software. Friends, in the whole NFIS series, following topics will be covered. Number 1. Why adaptive neuro-fuzzy inference system is needed. Number 2. Limitations of the fuzzy logic controller. Number 3. Basic introduction of the NFIS. Number 4. NFIS implementation in MATLAB using GUI tool. Number 5. NFIS implementation in Simulink. Friends, adaptive neuro-fuzzy inference system has very large applications in the different areas, especially in engineering sciences such as electrical engineering, mechanical engineering, civil engineering, electronics engineering, telecommunication engineering, control system engineering, chemical engineering, robotics, industrial process and control. And still there are many other fields where NFIS can be applied. Now let's start. First, I am going to discuss why NFIS is needed. Before going to discuss this point, it is worth here to mention that the word NFIS stands for Adaptive Neuro-Fuzzy Inference System. In other words, the NFIS is the combination of artificial neural network and fuzzy logic controller to provide the best performance. Now question may arise that why artificial neural network is combined with the fuzzy logic controller. To highlight its need, it is better first to discuss the limitations of the fuzzy logic controller. Friends, if you remember, in the third part of the fuzzy series on how to implement fuzzy logic controller in MATLAB Simulink software, I have discussed the limitations of the fuzzy logic controllers. In that video, I discussed that fuzzy logic controller has the limitation that it is not expert by itself. In fact, it needs an expert to make it expert and provide the best performance. Therefore, if expert assigns the wrong rules, then fuzzy logic controller may provide poor performance even than the PID controller. Furthermore, most of the times we don't have sufficient knowledge about the behavior of the system. Therefore, while implementation of the fuzzy logic controller, we are not sure about its correct rules, due to which most of the times we use hit and trial method to assign the rules and try to obtain the best performance. Now question may arise how to overcome this limitation of fuzzy logic controller. Can you think what is the possible solution to overcome this limitation? Friends, in order to overcome this limitation of fuzzy logic controller, artificial neural network can be used to make the fuzzy logic controller expert by itself. I repeat, artificial neural network can be used to make the fuzzy logic controller expert by itself, because fuzzy logic controller is not an expert by itself. Now again question may arise, what we need to make it expert? Friends, it's quite easy, as we know that the artificial neural network requires input and output data only for its training. Therefore, all we need is the input and output data of the system only to make it expert. Based upon this system input and output data, ANN learns the system behavior, applies the correct rules and assigns the correct membership function values to obtain the best performance. It may be noted that among artificial neural network, fuzzy logic controller and NFIS, NFIS is the most easiest and accurate technique to get the best results. All you need is the basic knowledge of the both ANN and fuzzy logic controller and its implementation in MATLAB. For your convenience, I have already made the video series on artificial neural network, namely how to implement artificial neural network in MATLAB Simulink software in 4 parts. Similarly, I have already made the video series on fuzzy logic controller, namely how to implement fuzzy logic control in MATLAB Simulink in 3 parts. Therefore, you may watch those videos for better understanding of the adaptive neuro-fuzzy inference system. Now let's discuss about the basic introduction of the NFIS. As discussed earlier, the acronym NFIS derives its name from the Adaptive Neuro-Fuzzy Inference System. NFIS method is based on the combination of artificial neural network and fuzzy logic control. ANFIS is a very powerful approach for modeling non-linear and complex systems with less input and output training data. It combines the advantages of ANN capability in learning from the processes and fuzzy logic controller capability in handling the uncertain information. This makes ANFIS capable of approximating non-linear and uncertainty systems without requiring pure mathematical models. Consider the figure which shows the typical ANFIS structure. It can be noticed that ANFIS consists of 5 layers and each layer is connected through weights. In the first layer, which is known as input layer, the received input data is mapped into membership functions to determine the membership degree of that input. In the second layer, fuzzy rules are used to relate between input and output. The third layer normalized the output and passes to the fourth layer. The fourth layer maps the output data and provides the output membership functions. In the fifth layer, the outputs are added to provide a single output. This is the whole procedure of the ANFIS. Friends, you can see ANFIS is the simplest but most powerful method for providing the best performance. I will teach you further in my next video on how to implement it on power system model in MATLAB Simulink software. However, in the end, it is better to discuss few limitations of the adaptive neurofuzzy inference system. Friends, ANFIS has the limitation that it can work for Sugino type fuzzy inference system only. It means that ANFIS cannot be implemented for Mamdani fuzzy inference system. Furthermore, it has another limitation that it can only be used for one output only. It means that ANFIS cannot be applied to those systems who have more than one outputs. Friends, in this video I have basically discussed the need of the adaptive neurofuzzy inference system. Furthermore, I have discussed the limitation of fuzzy logic controllers and I have discussed the basic introduction of the adaptive neurofuzzy inference system. In the next video, I will teach you how to implement adaptive neurofuzzy inference system on any engineering model in MATLAB Simulink. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel and share this with all your friends so that they may also get benefit from this video. Thank you very much.